Hey everyone, welcome to my stream. So, last stream was really exciting because we finally got to a point where this thing I've been working on of trying to synchronize two instances of my emulator, each with a different CPU implementation, and basically trying to find desyncs between them actually started working. And where we left off last stream was we found a difference between the two runs in terms of the inc.b instruction. Now, I left the stream just before looking into fixing it, and the next day I just quickly looked at it. It was really no big deal. It was a dumb mistake really, but basically the increment instruction, I was setting the overflow flag incorrectly. Basically, overflow always has to do with interpreting the bits as though it was a signed value, so like a 2's complement value. And so what overflow means is basically we increment the value and the sign changes. And that's why, as it says here in the docs, if you have this value here, which is the largest unsigned value, and you were to increment this by one more, suddenly this unsigned value would become signed, and that would be the one case where overflow would get set. That's not what I was doing. In fact, I was basically treating it as though it were an unsigned value. So, you know, I had this here where it was like, if the value suddenly became 0, it overflowed. That's incorrect. So changing it to this actually fixed it and allowed me to move forward. So that takes care of that one. But before like you can see here, I stuck it on a branch here and decided to just take a moment before I go ahead and start, fixing a bunch of CPU bugs, which is the purpose of this system. I just want to kind of finish up the system and clean it up, fix any outstanding issues, and I want to basically merge this network compare branch that I've been working on back into master in a clean way. So I'm just going to spend a little bit of time at the beginning of the stream just cleaning this stuff up. And then we can resume looking for CPU fixing and looking for CPU bugs. Okay, so a few things I thought about is, since I'm not going to be sending back and forth anymore per instruction, and I'm only going to be doing it once per frame. Right now I have this code here at the bottom of my debugger's update. I can actually hoist this out and put it back right into main, which would actually mean that the only place I have this networking code would be in this one file, which kind of makes me happy. Say I have the sync protocol, and we where is it here? Yeah, this msync protocol instance lives. It lives in my Vectrexy instance here, which is basically like the the main class for the emulator. So I have the sync protocol. We created here, we initialize server and client, and then we have some stuff there. And in the update, here we check if I'm the server, we got to send the frame time and inputs to the client. If I'm the client, I receive it and use it. That's good. And then we had this passing down of the sync protocol to the debugger. But in fact, we really don't need to do that, because now that all we do is wait till the very end of the update to send this instruction hash, right? Like what I'm going to do instead is I'm going to have it so that this instruction hash can be queried off the debugger. So we do an update, or maybe have it be returned by the update. I don't know. Right now, update returns a bool. Oh, hey, Blue Dragon. How's it going? So yeah, so that's what I'm going to do now. I'm going to just hoist this code out. You're gonna do some drawing? Yeah, man, that's cool. Sounds good. What was this again about? Sync construction hash. All right, and then we want to stop doing this. Okay. Yeah, I'm gonna make these into members. So we're gonna need to figure out when to set this to true actually. So we'll do that. Where do we do that? Maybe on the outside. Okay, so we'll do why is it again that I even have that bool? Alright, I use this to know whether you know what, I don't need to do this here. So I don't need this. So forget about that. What I do need though is this instruction hash. So this is a hash of instructions per frame. Something like that. We need to make sure to reset that. Alright, and then this is where we do our work. I'm going to put this in a function. Okay, let me just search and replace here. Yeah, this hack here, not necessary. Oh yeah, that's right. There was a reason why I'm doing it, putting it in the log. Yeah. Okay, I'm just gonna explain this hack here. Hack, Vectrex, CPU implementation, sets half carry differently than we do for when it's undefined. So for now, as we compare trace logs, we just ignore this field. Something like that. Okay, so we've got this. Let me just stuff this into a helper function. My CRC is here. We'll call this hash instruction. So this will be the current instruction hash, and then we'll give it a trace info. And then we'll just do everything that we did here. So actually, current instruction hash. Okay, so this will be like the start one. We actually want to return it. instruction trace info? Yeah. Alright, so let's see here. This is correct. And over here, compute the running hash. So we'll just go like this, instruction hash. No? What was it called? Yeah. And I need to give it a trace info.
You know, back in the mother country.
Is this where I come in? I am the square, you can put me over there in the middle or the corner, I don't care. Look at me, perfect symmetry. Rotate all you want, it's the same you see.
So now we have this in a function, we are collecting the hash. Now we need to be able to return this. Just think about it, I don't even need to really ever reset it, do I? Doesn't really matter. Even if I never reset it here, it should still work. Hey Lolzone, you ask if you can ask me for some help in my free time? What with?
It is I, you are wonder why there is so many lines.
Just wondering if I should return this from my update. I think I'm just gonna make a function to return it for now. Okay, so we'll turn it like this. Okay, now the next bit is we're no longer going to pass in sync protocol, so let's get rid of this. Yeah, all of this is going to disappear. So this is gone. I think my include. Actually, let me do this here. Here. And now this code here has to be removed. Sync hashes and compare. Alright, let's just rip it out. Oh wait, including this has mismatch crap here. Alright. Let's go into main. Your group has to create an old school game, and what is a good way to create classes, stats for characters and monsters? That's a kind of a broad question. And you're saying specifically using C++? Have you done this in, like, are you familiar with how to do this in a different programming language, and you just want to know what the analog to doing it that way would be in C++, or is it more like just generally how do you take care of implementing stats and stuff like that for characters in general, not just in C++? You're new to programming? I think it's kind of a tough question. I could see why you wanted to ask me in my free time, but we did Python before, but we have to make one in C++. Well, would you know how to do it in Python? And when you say an old school game, like, do you mean like an RPG? Because you're talking about classes and stats for characters and monsters. Or do you mean like a Zelda-like? So if we're not a server and we're not a client, we are standalone, for lack of a better name of this. So yeah, so what kind of game are you talking about? Because I mean, generally speaking, you know, when it comes to defining, like, I guess it's like an RPG, but very basic, just going through a maze. I mean, there are really a lot of ways to do this. I mean, one way to kind of handle that is the, you know, very object-oriented way, which is, you know, have some kind of like class character or something, where, you know, you put all your common character stuff here, and maybe you'll have class hero or whatever you want to call it, which is itself a character. Maybe you want a class monster or enemy. So that's like one way to do it. More like this is the approach that's kind of classic object-oriented. There's some there's some simplicity to this model, but it can also get quite kind of complicated if you go a little too deep. But does allow you to have, you know, to share certain things. The more kind of modern approach to this is to go with you know, a little bit like what Unity does, the entity component system. So the kind of thing where you want to like have very thin, like not deep hierarchies, but very like shallow C++ hierarchies. And what you do is you have these components that you add to your entities, to your game objects. And these components basically define the behavior. So it's a bit more complicated, I'd say, to kind of set up for if it's your first time and you're new to programming, you might actually find that more complex to get set up into your engine. But ultimately, it is actually easier down the line. So those are kind of like two strategies. So like a kind of a taste of the other strategy would be like, let's say you'd have some. Let's go with like game object, because that's what Unity calls it. So you'd have like a game object is something, and let's say we go like class component or game component or whatever, right? So you have some kind of base class component, and you have this concept of a game object which has, let's say, private or protected, a vector of, and I would probably use, if you're going to use some modern C++, maybe shared pointer of type component. So something like this. So then the idea here is to have like functions, like add component, and you want to be able to add one to here. And I'd probably make this a template so you could specify the type. And this is what I mean where it can get a little bit complicated is in the details here. Let's say component T. But okay, actually let's say we don't do the template thing. So you'd want to have like a function to be able to add a component. Probably by shared pointer or unique pointer. And you'd want to say push it back. Something like this. And then you'd want to be able to query them, so you have to worry about like finding a component by type. So dealing with run, you can use RTTI and dynamic casts to find the one you want by type. And again, here I would use a template to say I'd like to get a component by let's say you have there's different kinds of components that you'd have here. So for example, so this would be like, let's say your system, and in your game you'd create components. So let's say like I don't know, physical component is a component, and what this guy does is it defines like the behaviors for objects that move in the world following physics, physical properties in your world, like gravity and doing collision detection. You'd probably have like a physics manager, and the components would register themselves to this manager so that it can do the integration every frame to move things and see if they collide and call back collision handlers, stuff like that. You'd want to maybe write your like player controller component, and like this would be the one that you would add on your hero, and this would be, oh hey AK Sniper, thanks for the follow. So the player controller component would be the thing that would be querying inputs, like joystick and keyboard, and its job would be potentially to say if you have a physical component or something. Let's say you have a physical component, maybe you're setting the forces for movement on the physical component, So like that's one approach. And this is like a more modern approach, like I was saying. And then like ultimately you'd want to have classes. Let's say you have your hero class. So your hero is well, it's actually you don't really need to make it a class. What you'd want to do instead is say like define an instance of your game object, which is a hero. Now most likely it won't be on the stack like this. You'll probably want to have like a vector of game objects. Hey, oh, thanks for the follow, lol zone. So something like a std vector. Again, I'd probably use shared pointers. Keep things simple. Think of shared pointers kind of like a garbage collected type in C# if you're doing Unity. AK Sniper, you're saying you're learning C++, trying to understand how to break loops is killing you? Really? In C++ specifically? So like, let's say you have some game objects somewhere, some manager holding all your game objects. Maybe it's a global that has all your game objects. But the point is, it would hold these game objects, right? and you'd want to push back on there something that you've configured. So like a hero looks like, so let's say it'll be more like auto hero equals to make shared. So we make ourselves a game object, and then we say, all right, and let's add it as a component. And then here I'd want to say like something like I want to add a player controller component, you know, and I probably want to add, you know, this is what I was saying, I would use templates for this. It's also physical. And I don't know what else. You'd like add a bunch of components, right? And these components need to be able to discover each other. Like I was saying earlier, the player controller component might want to grab the physical components. I consider these like sibling components, right? So these guys need to be able to access their owner game object to the container that has them and ask, hey, you know, do you have a physical component on you so that I can grab that pointer and or get a shared pointer to it and maybe store it so that I can talk to it and tell it things. So that's a very kind of Unity-like approach, but applied to C++. And in fact, I actually did implement this kind of system. Oh, hey, Backface Color. Thanks for joining. It's your first time, right? So, okay, so if we go on, and I haven't looked at this code in a little while, but a couple years ago, I actually wrote something like this. If we go see, where is it again? I think, did I do it in the Star Fox code base? Oh, second time, cool. So yeah, so I think it might have been in my little Star Fox thing that I worked on a few years ago. Let's see. Even though I committed in 2016, I think I had worked on it more like in 2015. Let me see if it was in here. Yeah, I think here I call it scene node. Yeah, I think it's all this stuff here. This kind of scene graph, scene node, scene component stuff. So, let's see here. See, I even have these try get sibling component helpers and get sibling components. So one of them will return null pointer if it can't find it. The other one will assert. And what else? It's got update and render. It's been a long time I haven't looked at this code, but so this is the concept of a component. And then you have a, hey Mr. Anderson, thanks for joining. Okay, so yeah, so then this is the actual scene node. So think of this as the container type. So I like functions like destroy nodes and all its children. So the thing with the scene node here and the concept of a scene graph is this kind of like, so in Unity they have this component which is the transform and it's handled separately, but in my case, scene nodes and transforms go together. Like that is actually what a scene node is. It's a node in a scene graph that has a transform in it. So actually we should probably see a transform somewhere in here. Yeah. Here's all the transform stuff. And I think my transform, it's a matrix 4-3, so, and it's a bit more than just one thing. I think I store, where is it again? Here. So I store local to parent and local to world transforms here. And this is basically just like a kind of like an optimization is when you can make scene nodes children of other ones, just like in Unity, and it is able to track like its local transform to its parent and its transform to the world, and it updates them lazily when it needs to, so it's as efficient as possible. So yeah, so I have this whole thing with like being able to attach scene nodes, detach them, take a scene node like and all its children and destroy them all. And it's using shared pointers under the hood, so all that stuff works. Yeah, this was some pretty fun stuff. I'm remembering now, looking at here, like I have this function called flatten subtree, where adds this node and descendants to input container. So yeah, so basically like, let's say you'd want to iterate over a subgraph, or let's say all your scene graph, you could flatten the entire thing into this stood vector of these scene node shared pointers, and that just kind of gives you this one vector that you could iterate through. So stuff like that, you know. So this was pretty cool. And then I have the scene graph here, and then the scene graph is the container of all scene nodes. So this is the guy. Let's see here. Get all scene node snapshot. So yeah, so this is the system, you know. So with this is a pretty good starting point, I'd say, if you're looking to have something similar to Unity. And I use it, I think, in my Star Fox game to like build up the Star Fox ship and attach things together. I didn't really go that far with it, but and this GS game lib, this is actually like a separate game lib. It's not tied to the Star Fox thing. It's just one of the libs that's used. So there's the game itself. Let's see if I can find the stuff that I was doing, because I see I have like anchor component here, camera component. Okay, so here's an example of usage. So here I went and I created a ship. Then I loaded the static mesh, and I did add component, static mesh component, and so I added it. It actually returns it when you add it, and so you can call functions like initialize, and I give it the static mesh. So the ship now has a static mesh component that it's going to use for rendering. I also add to the ship the player control component. So this is the thing that I was saying, like, it will be used to control, the player can control this ship with this component here. Like I was saying, like there's this concept of the scene node has a transform, so you can go modify local to world, and I set it to start over the ground. Here I create a scene node to represent the ground, and I added actually a component called ground component, which I'd have to look at the code for what that is. I think if I recall, it's just this big, you know, plane that has that when it renders, it moves these dots towards the camera to give you the illusion that you're actually moving, but you're actually not moving. I have this thing called an anchor, which I don't even remember what this is. Oh, okay, anchor, and then I attach the ship and the ground. So it's something that has this ground and the ship as its children, probably because it's doing something related to those transforms. I don't remember now. And then I create a camera, and I have these different types of like targeting camera components. I have an orbit target and a follow ship camera component. So you can kind of get the idea of like the power of this kind of system. And again, if you've used Unity, none of this is new. So that's, I don't know if that helps you, lull zone, but yeah. So that's one approach. And then of course, like I was saying, the first approach I was showing is more like the classical, maybe more straightforward if you're just learning how to make games and object-oriented, where you try to identify these more, how can I say, less entity component and more hierarchical based approaches. And these can be a little bit simpler, I think, when you're starting, but they get kind of hairy rather quickly, you know. I think the classical one helped more. Yeah, I can understand, especially if you're new. Like what this here is fairly advanced stuff. So the classical one is more like, yeah, you know, and again, you know, you might actually go. This is typically what happens. You'll be like, actually, a character is a game object because there's other things in your world that are not characters but will share certain functionalities that other game objects in the world will have. And so you'll probably use something like this because maybe, I don't know, you'll have like a trap in your world will be a game object as well, because maybe your game object is the thing that has like a position in the world, you know, like something like that. So we decide all game objects have a position in my world, you know, or in a rotate or a transform in general. And so a trap will have one as well, you know what I mean? And then you'll probably find yourself wanting to put some virtual functions there that they all have. So maybe an update function, you know, a draw, something like that, right? And then you can have this big array of game objects, and you just kind of every frame just go and update them all and then draw them all. So this is the most straightforward as it gets. Now you know you have these nice hooks that you can use for your stuff. So maybe that's, you know, for beginners, I think this is a pretty good approach to start. You're making me want to get back into game coding. It's been a little while. At least on personal projects. Still doing it at work, of course, but hey, no problem, man. Alright, so what was I doing? Sync hashes and compare, yeah. Oh yeah, now I remember. I want to say if sync protocol is... So if I'm not standalone, then I want to do... So get the instruction hash from the debugger and okay, we want to send it here. So what's the problem? Okay, it'll be defined soon enough. Got the server instruction hash. Right. Yeah, that's the only thing is we're gonna want to also query how many instructions since the last frame because we want to output that here. That's all right. So let's make that a data member as well, I suppose. I have like two choices here. I could make it that the debugger returns this stuff. I don't know. Something like this. I mean, to be honest, this is a bit of a leaky abstraction now. But it's okay. I still prefer doing it this way than putting the protocol into the debugger. And I mean, asking the debugger for stuff like that's no big deal. Okay, so why is this not... Is this like a scope problem? No, this is... Oh, right. Yeah, that's why. Okay. Yeah, and I'm gonna have to expose this break into debugger function. Nah, I don't know anymore if I prefer this. I'm starting to make a lot of stuff leak out of the... Yeah, you know what? Let's go back. Sometimes you start doing something and you realize that it sucks. Okay, this is fine here. Yeah, so actually I don't really need this to be a static like I had it before, so I do like, since we know we're gonna be disconnecting in this case, so if we're not standalone, so we'll just go back a bit here. Yeah, actually I will make this into a data member. That's fine. Back to main here. Okay. So just to see what this looks like. Okay, so yeah, I'm gonna need to reset this bit. I'll keep that, keep this, keep this. Alright, so this should pretty much bring me back to what I had with a little bit of cleanup. Hey, Cinecron, how's it going? Oh yeah. Just since I gotta run CMake again. Why did that do nothing? Oh, is this the project? Yeah, this must be. Yeah, okay. 9Y, build, Vectrex CPU. Okay. It's gonna reload, build. Alright, so that built. So, I mean, in the end, I am gonna keep this because trying to rip it out actually kind of exposed way too much of the debugger than I liked. But we can at least tuck this into a little function. Let me see, instruction hash. Think whether to continue or stop. I'll say sync instruction hash. Oh yeah, I'm gonna need to pass the sync protocol here. Yes, Snake Eater. It's a good tune. So we'll go like this. Now we can early out here. So if we're in standalone, we have nothing to do. But not this specific song, right, Blue Dragon? Sinachron wants me to lower or mute the music? If you don't mind, Sinachron, I kind of like to stream music on my stream. Unless I get like a lot of complaints about it. But I feel like what it does is, especially for the videos that I put up later, it kind of allows me to be quiet and think, and for at least there to be something in the background. No, not this mix. Yeah. But if people find it too loud, I mean, when I listen to the streams afterwards, I don't feel it's too loud compared to my voice, but you know, if I get comments about it being too loud. Alright, well, thanks for hanging out, man. Okay, so this builds. Now there was something else that I was thinking about. Let me just see here. Okay, no, I think this is good. Let me submit this. And I'll just say clean up sync protocol code in debugger. So the last thing I wanted to do was, it's a bit annoying right now when I build with a Vectrex CPU. I need to do a small change that I can build without having to constantly toggle this flag. So let me get that done here. So actually, before I do that, let's just make sure this works. So if everything is working, oh yeah, there's another thing I need to fix. It's true. So let's see if I run Vectrexy in server mode, and then run it in client mode. Oh, that's interesting. A mismatch already detected. Okay. Usually when that happens, it's because, let me see here. Oh, and they're actually frozen. Okay, so I killed one of them. Alright, so why would I get a mismatch right off the bat? I wonder if it is because I'm not resetting my hash, even though that doesn't make much sense. Because I mean, if we're in sync, but just to double check, let's say I do this. Because that's, I think, one of the only functional changes I made. Oh, no, I know, okay, I know exactly why. No, okay. I'm not running the same version. Yeah, this makes perfect sense, okay. Because basically I have two builds that I make, one with my CPU and one with the Vectrex CPU. Right now I kind of reverted the Vectrex thing, so the client is under the build Vectrex CPU here, but my server is under I don't know, it's not server. I must have killed the anyway, the one that was titled server before. Code, what was it again? Yeah, it was build 2017. So if we go into the same folder now, so we launch server this way, and launch client. Okay, so now they're in sync. And you know, these shouldn't desync because they're actually doing the same thing. And they're sending each other the instruction streams and making sure that they they don't go out of sync. You see, they're even sending each other inputs, and so everything should remain in sync, right? So this is what I got working last time. So that's pretty cool. So that's still working. That's good. A couple of things that I need to fix. So one of the things, if I try to launch the client first, that just crashes. Like I get this crash. So that's one thing I'd like to fix, but maybe I won't fix it right now. Not super important. What was the other thing? Oh yes, okay. So let's do the CPU fixes. So let's say I grab this, so I'll cherry pick this change here. So we're back now to having the, oh no, sorry, I cherry picked the wrong one. Reset. What I meant to cherry pick was this, the Vectrex CPU integration. Okay, so here we go. So for this, I will need to run the CMake thing again. So what I want to stop doing is having to define this here. And the way we're going to do that is we'll say if it's not defined, then define it this way. And then what we'll do is we won't define it for the main emulator, but we will define it to 1 for the Vectrex one. So that's it. So let's see how that works. So this is the Vectrex one. So in the properties of this project, C++ preprocessor. And again, this is totally like temporary, but we'll go in here and we'll say equals to 1. So I define use Vectrex CPU implementation to 1 for this version. So when I build this, see in Visual Studio it even sees that it's defined from the environment, so that's good. So this is a version of my emulator built with a CPU implementation from another emulator called Vectrex, right? I'm going to open another version of Visual Studio, and I have, so actually I want the server to be using mine, so let's say build 2017. And that'll be this one here. Now this one I won't define that preprocessor macro, so this should build with my CPU instead. So here, this one here. If we just wait a second for Visual Studio to parse, you see this guy is 0 because it's not defined in the environment. So when I build this guy, and this will just avoid me having to keep toggling this thing, and it was kind of frustrating for me because I would set it to 1 and have to build one, set it to 0, build the other, and I couldn't debug the two, and so this will solve that problem by moving it, basically moving the definition out of source and into the environment, which is what I should be doing. Okay, so now if I run release with debug info. So now if we run this guy as a server and this one as a client, we will get that desync that we hit last time in the increment B So that's what we should get. And there we go. So we got some kind of instruction. See, it says instruction hash mismatch in the last 40,271 instructions. Same over here. A bit annoying though that we're not breaking into the code. And this I know what this is related to, but I thought I had fixed this problem. Yeah, very frustrating. So this is related to the problem I saw last stream. Let me just kill one of these so that we don't lose everything. Vectrexy. Yeah, so this is... I tried to address this issue. There's a deadlock that occurs when we try to bring the window to the top here with the set focus. Sometimes it works, sometimes it doesn't. I've had like varied results with it, but it really does seem like this is just misbehaving in terms of what Windows wants us to do. Well, what I could do is I can go back to what I had before, which was rather than call break into debugger, here. I really do need to fix this at some point, but I won't do it on stream because I actually have no idea how to do this properly. But it's not a big deal. This only really happens because I have two... I think I did not... Yeah, there we go. Because I have two versions of the same application that are trying to grab the focus exactly at the same time. And that's when I'm hitting the deadlock situation. Alright, so let's try and speed this up. Okay, so now we actually correctly stop in here without being deadlocked. We can see that we got the same mismatch in the last same number of instructions. So then what I do is I say, let's trace this many and write it to a file. So I'll say trace my CPU, and let's dump the trace for the same number to Vectrex CPU. And just like last week, we want to compare these. And there's the increment B problem, right? So the main difference here, the first difference is an increment B, and the difference is that on mine, overflow was not set here, and Vectrex actually does set it. And Vectrex is correct here, because B is 80 in hex, which is basically so B is 80, so what we're looking at is a 1 over here. I think this is after the fact. Yeah, so if we look before, it was at 7F, so that's the problem. It was 7F. So it's basically exactly that case where you have a 0 in the highest order, the most significant bit, and then 1s everywhere else. So this is a positive number, see decimal 127, and then as soon as we increment this, this guy goes up to 1, and actually let's change this to byte here. And all of a sudden we became negative, right? By incrementing by 1, a positive number became negative, and that should set overflow. So that's the bug here, right? And we were able to find it due to this syncing feature, which is really cool. So, okay. Everything's working. So let me just get us into a mode where we can keep working on stuff like this. Unfortunately, we still deadlock when multiple instances call break into debugger at the same time. So for now, just don't do it. Temporarily undo break into debugger to avoid deadlock. Still happens. Okay, commit that. Okay, so reset. Okay, so now I'm gonna just merge this into my main branch because it's time. I like to create a merge commit because I like to see the work that was done. See, now we have this. This is the branch that I worked on. We merged in here, so we merged in network compare. So we're good with that. So now, this is what we do. Now we cherry pick this again. Oh yeah, and I forgot to make that. Yeah, I knew I forgot something. Okay, no big deal. Took 2 seconds. So cherry pick Vectrex CPU integration. Okay, let's just get this checked in under this branch again, Vectrex CPU integration. So I'm going to just do here, little git stuff, git branch -f Vectrex CPU integration. Let's move that to head. So we should be up here now. Let's check it out. So I'm just going to update that branch with this little fix that we made. Steal the same thing. I'm going to have to force push this. Okay. Okay, so we're here, we're back on master, and we are going to, once again, we're gonna just cherry pick this. I just like to do this because I don't want to keep this change, it's temporary. All right, so we've got this, great. I'm just gonna unstage them. So we're back where we were. What happened to my, oh yeah, okay. So now we can grab the fix that we made here. And I guess it doesn't want to because I have local changes to my CPU, yeah. I thought when I cherry pick it would actually ask me if I want to perform the merge. But I need to have this committed for this to happen. Okay, no big deal. We'll just reset this because I don't need it right now. And in that case, we will actually... Yeah, you know what I'm gonna do? I'm gonna, since I have it already in a branch, CPU fixes. No, forget it. I'm just gonna cherry pick it. All right, so now we move ahead with that overflow fix that we just talked about. I'm gonna push master. Okay, so now we're finally ready to keep going. So this is, yeah, this is mine. And then the other one here, I have this defined to 1, yeah. And now we're going to find the next desync and see if we can fix that one. And basically, we're on the quest to fix the CPU implementation. It's a bit confusing having two versions here. Let me just make sure I've got the right one. Okay, so this is the Vectrex one. So I think I lost the define because I rebuilt, I did the CMake again, yeah. I won't really be doing that again, so should be okay. So we're just about ready. All right. So once again, server and client, let's spin them up. Okay, so see, we got a bit further. Before we didn't even see the ships, now we see them, and we've got a mismatch. So let's see what the next mismatch is. So we'll go back to, I think I have, yeah, still in the history. We want 34, 612 for mine. And similarly for Vectrex here. Let's go look at the diff. Alright, so it's rotate left that has a difference. And in this case, it looks like the difference is in the setting of both the negative flag and the overflow flag. Okay, so rotating indexed by X, let's see. So we are reading C87D, because that's what X contains. So this is an absolute read, and then rotate left. In there is the value 40, but I think this is afterwards, right? Right, so what that means is that $40 and we wrote back 80. Right, so exactly, so it was 40 and then we ended up shifting left by 1, which effectively does this, tuck, like that. And yes, once again, this should be setting overflow and negative, right? Okay, so let's go see why mine is not doing that. So up, rotate left is here. Strange, this should have worked. Like specifically negative here, let's see. Ah, right. Probably should be doing this not on value, but on result. So there's the bug. So I get value and we compute a result, and then we don't use result for computing all these things here, including the carry and 0. Okay, so 0 is using result. And then the carry. Now the carry, did I want to use the previous value for this? Maybe. I want to see, yes, I want to see if bit 7 was set before we rotated left to know if carry would be set. So this is correct. But for overflow negative, we need to look at the, and actually, okay, negative, yes. Let me think about this overflow here. So overflow would occur if one bit was set but not the other. Now we're rotating left. Yeah, so if there was a 1 and then we rotated left, it would go from being a negative number to being a positive. So that's also. So we look at bits 6 and 7. Now if both are 0 or both are 1, we should be okay, but if 1 is 0 and 1 is 1, we have a problem. Let me see something. Yeah. I think, could it be just because of the fact that we are not comparing to 0 here? Let me think here. Yeah, this math's not right. I would need to shift, that's why. I would need to shift these bits to the right. Like this has to be shifted right 7 times, the other one shifted right 6 times, and then we could do the XOR of those two values. What was I doing in calc overflow? Right. So I do value and bit 7, right shift 7. I think it's like this. So we bring these basically to the bit 0 position, and then we XOR them, and only if those two XORed are not equal to 0 means one was set and not the other, and then technically this should work. So let's see. Oh yeah, need to kill my executables. I guess technically I don't need to build this one here. Just easier though. Okay, so both are built. On the server, on the client, let's see if it still happens. Okay, so we still have a mismatch. So I probably didn't get it right. Let's see. Oh, this time it's rotate left. No, sorry, that is still rotate left. Okay, so I did something wrong with overflow here. Okay, let me just check something. So this is rotate left. Loaded with the result of B7, B8 of the original operand. So what's this operation they're trying to show us here? B7, B8. Doesn't even make sense. Let me try something else here. Actually, I really should be working in this guy here, because this is the roll. Yeah. Sometimes the frame rate just smooths out. So strange. And then it drops. $39,921. Let's see here. So I'm not sure if I fixed it, but now we've got, instead, in this run, a difference at the line where we rotate right instead. Now A would have been 10, and it looks like it ended up being 10 again, which is doesn't make much sense. Wow, I can't believe how many bugs are in this code. I compute a result, I compute the flags, but I don't actually set the value for rotate right. Amazing. This is great. So we see that the system is working. So let's see now. Let me just close these windows here because I don't want to get confused. So the Visual Studio without any windows open is the Vectrex one. This one here is mine. Oh, well, we're definitely a lot further now. This is cool. So it looks like I did fix correctly the rotate left overflow computation. What I did was, instead of shifting right the two values into the low bit position, I decided to just shift the bit 6 left 1 and then XOR those values. So that looks like that's probably even more optimal. Just want to finish one level just to see if we remain in sync. You know what? I'm gonna plug my controller. Of course, the fact that we're not running at a smooth frame rate here is not helping, but it's okay. Gotta be more careful. But so far so good. No desyncs. But we're like running at 8 FPS here. So it's a bit difficult for me to play. There is something I wanted to try. You know, I was watching Ferris's stream last Thursday, I think it was. He did this really great stream where he went over his emulator tech, and he said something that I hadn't really thought about, and it made a lot of sense. Where he said that he basically introduces this sleep each frame. Because he said, you know, not like if you try to run your CPU as fast as possible, you end up like executing with too small a delta time. You kind of execute too many instructions, or like, I'm sorry, I mean not enough instructions for it to be worth it, and you kind of get like this overhead in the emulator. And so I actually don't have a sleep like that, and I was thinking maybe that would account for my high CPU usage right now. Or just in general, that I should introduce at least a small sleep, or I should at least look at the measured delta time, and if I see that it's too fast, if we're running too fast, I can put a little sleep in there, and then that should reduce the CPU usage. And maybe, well, maybe things like this would go faster, because if we had longer frames, we probably, yeah, we'd be syncing over the network less as well. I don't know. I don't know if that makes sense. Okay, well, this is pretty awesome. So we fixed, so far, 3 bugs in the CPU. We fixed one in increment, one in rotate left, and one in rotate right. So Blue Dragon, you're asking if the Vectrex has a refresh rate in the traditional sense. Not in the traditional sense, which means, you know, you're talking about like when we talk, say, 60 FPS or 50 for PAL, and like that basically has to do with the fact that the beam moves, you know, from top to bottom, left to right, at a certain frequency, right? And you have this concept of VSync. Yes, exactly. Knack Hackett, exactly. Yeah, basically like give myself a fixed delta time, and then and you say 50 because that's effectively the refresh, like the refresh rate of the Vectrex. It's not really a refresh rate. Well, I guess actually it is technically what the refresh rate would mean logically, but in the case of the Vectrex, we're just talking about the beam moves around, and the phosphors that get excited by the beam, well, those decay over time. And internally in the BIOS for the Vectrex, there is like a wait function that you're supposed to call once per frame, and what it does is it does effectively give you like a 50 hertz logical time. So it's like counting cycles, and it's saying we're going to count as many cycles, we're going to wait a certain total number of cycles, such that we achieve a 50 hertz effective refresh rate. Because, you know, anything longer than that, and on the real Vectrex, you're going to start to notice problems like wobble and drift. Okay, we just got a little, I know this is a separate bug where we start reading from unmapped memory, and we'll just kill this now. Yeah, so what was I saying? yeah, so that's it basically. To answer your question, Blue Dragon, it's not really we don't have a vertical retrace basically. But that's it. If you wait too long and you don't do this kind of reset functionality that BIOS offers you, where it says like I'm gonna move the beam back to the center and do all this stuff, you kind of get like wobbling effects and drift effects. Okay, so let's see here. So these here are the fixes for CPU. So I'm going to say fix rotate left, not computing overflow and negative flags correctly. You know what, I'll do this in 2 bits because I kind of like keeping these separate. So it's hard to say what your fixed time step would be then. Yeah, I mean it's supposed to be 50 Hertz. I'm trying to remember, I think it's something like 30,000 cycles, and that's at 1.5 megahertz, and I think that works out to 50 Hertz, is that right? For 30,000 cycles. Yeah, so Nak Hackett is saying using the timers. I am actually using the timers. That's how I compute my delta time per frame. And what my emulator does is I measure the time since the last frame, and then I use that amount of real time to determine how many instructions I need to execute. I can actually show you that code. I'm just going to commit this here. Fix. This is fix rotate right, so that it actually stores, so that it actually, what do I want to say? So that the result is stored. There we go. Yeah, so like starting at the engine level, this is where we compute our frame time. So I have this update frame time here, where I'm using the high resolution clock. So I keep track of the last time. This is a static, and I compute the current time, and I subtract the 2, which gives me a diff, and then that's the real frame time here. And then I have this stuff where like I clamp to make sure that we don't have too large a delta time. But effectively, that's what we're doing, right? We're computing at a high resolution the delta time. So that's the frame time here. And that's what gets passed into the emulator. So here's the frame time, and that's what we use to sync and everything. Now, the interesting bit in terms of the CPU is that, here we go. So per frame, we're coming here and we're saying like our CPU frequency, which is 1.5 megahertz, right? We multiply it by the frame time to get how many CPU cycles for this frame we want to execute. And I have this variable that kind of keeps track of how many CPU cycles I have left to run this frame. Now this is actually a signed value, it's a double, because while it's positive, while I have CPU cycles left greater than 0, I actually execute instructions. So it's over here, execute instructions, and I get how many elapsed cycles that took, and I subtract it from the CPU cycles left. And so this means eventually I'll execute, let's say, if I execute exactly the number of instructions that fit into this delta time, that's great. But if I, most of the time, will execute like one more instruction that will bring us into the negative number of cycles, but then that negative gets taken into account the next frame when we add back the cycles for the next frame. And so we're basically, executing like one or one more or one less instruction per frame over time, and then that averages up to be unnoticeable. So that works. But yeah, to go back to the point of like syncing and stuff, basically I'm just going as fast as I possibly can. And I could, you know, probably in this function here where I'm like updating my frame time, just like how I clamp, I could make decisions here to like wait, because if I see that the real frame time is smaller than some value that I would like to hit, I can sleep till I, you know, sleep enough time to hit that, you know. So that's something I could do. I'm curious if I just stick in a sleep in here just for fun, just to see if it has any effect. Yeah, so I keep track of the so-called real frame time because of wanting to update my frame rate every second. But I think after that I don't do anything with it, or... Oh yeah, and then I compute a frame time based on that, clamping it so that we don't go any slower than 100 milliseconds per frame. So no slower than like I don't want a huge delta time. So what ends up happening is if we are too slow, it basically starts going into slow motion. Because, you know, like, if, let's say I remove this. If I remove this clamp and we run right now, what's going to end up happening is it's going to jump a hell of a lot. Yeah, exactly. That's right. I've done that before in other game engines. Basically, I want to hit 60 FPS, so if I'm going too fast, you know, I slow myself down to hit the 60. So this is I'm going too slow, and then there's the I'm going too fast. I guess I could do it here. Something like... Right. So something like this. And like I said, you know, I probably want to bring this down a little bit, but just to see And I would like to do a little sleeping here. Oh, actually, do I want to do it in a loop? No, I kind of don't want to do it in a loop. I want to do a sleep actually, right? Okay, yeah, so actually, let's not do it this way. No, so what we want to do is, it's kind of like a two-step process. We do this, and we compute this, real frame time, and we'll say, how do we sleep again with chrono? I haven't learned chrono very well. Oh yeah, that's right. It's through this thread. It's actually through the thread library. The std thread? This thread. And we want to sleep for, well, if we need to sleep. Thanks for the follow, Megano the Third. I think I need to include thread. Yeah. And what do I want to sleep for here? Can I I think I need to like convert this back into milliseconds or seconds. I think I have to do like std chrono duration or something. I don't know how to use this library. Chrono duration. Seconds. Hey, thanks for the follow, Nakhacket. I can't wait till I like know how to use this thing. I'm always looking up the documentation for std chrono. I think it's cool that we have it, but man, it's not obvious to me. Yeah, it's cool, right? Like it's great that we finally have something like this and the high res timer and it's portable. But I can never wrap my head around it. There's just lots and lots of namespaces and lots of functions and integer scale conversion with no precision loss, no cast. So it feels like I should be able to do like, okay, no, and what's sec here? Sec is seconds. 1. So yeah, it feels like I should be able to just pass in a value here. So let's try that. Thanks for the follow, Edster Gamer. So let's see, milliseconds to sec 50 minus real frame time, which is also in seconds. So it's something like this. Yeah, it doesn't look like it wants to work. So std thread has no member sleep. Was it sleep? Sleep 4. That's it. And then we give it a time. Okay, it doesn't like that this is double. Okay. I don't know. What does it want? Ints for this? Probably what I should be doing is, rather than using this real frame time here, is working with diff as a duration. That's probably the right thing to do. Anyway, let's just see if this actually does something. Like, I'm going through these problems because I've gone to double, but if I stay in this stood chrono duration, probably would work better. I'm getting the impression it's not actually doing what it's supposed to do. Yeah, it looks a little bit wonky. Yeah. That was fast forwarding, by the way. Oh yeah, so keep in mind that now I'm running the game standalone, not as a... So when I'm running it standalone, it's not doing any of the network syncing across two instances, and so the frame rates will be wildly different. This is like the way it's supposed to run. Yeah, so basically the speed, yeah, the big reason why I was running at like 10 FPS or less was because of the fact that I was syncing two instances and sending the hashes of the accumulated hashes of all instructions per frame. So that's really the major slowdown. The thing is, when I'm not streaming, it runs much faster. But I think when I'm streaming, my CPU is like so heavily being used by OBS that kind of gets in the way. Let me see if I could do this properly with the diff thing. So we have the difference from current time minus last time. Yeah, okay, one of the reasons this is also not right is because after having done this sleep, I need to recompute my current time and then update my diff for the rest. Because otherwise we're reporting a smaller time than what we've actually slept, right? So like we can kind of just cheese this a little bit and do something like this. Okay, so let's see how this feels. Yeah, I don't... What? Yeah, it doesn't feel like it's behaving correctly. It's like wild frame rate. What I should expect to see now is a frame rate that is, near 50 solidly. Let me think a little bit here. Anything weird going on? Oh wait, yeah, I did not update my current time. We'll get there. Yeah, no, yeah, and then you're right, I probably need to add a few milliseconds for instructions to not overlap. But still, this should get us like close, you know, like maybe 49 or something, 48. You know, maybe this is not even doing what we think it's doing. Wait a minute. No, this is not what I want. I don't want 50 milliseconds, right? I want like 1 over 50 milliseconds. Like I would want, if it was 60, it's 16.67 milliseconds. All right. I need to like rest my brain a bit and look at this again. I think I'm just not like I'm just hammering at it and I'm not really thinking it through. Shouldn't be this hard, right? Oh yeah, and I have the same problem. Okay. You know what I'm gonna do? Let's do this. Sounds like you all the time. Seriously, like, best thing you can ever do, right, is step away from a problem. As soon as I feel myself like hammering at a problem to fix it, I know that's the time to just step away. So I want to say, go take a shower, do the dishes. Yeah. I'm just gonna try one more hammer. Yeah, no. Alright. I know that. Does that ms to sec ever return an int value greater than 0? Should. So here we're going to be doing a double here. Yeah. Like. Yeah, I'm doing this all wrong, aren't I? It's 20 milliseconds we want, right? We wanted 50. I guess basically all I need to do here is not even put milliseconds to seconds. Just say we want 1 over 50 seconds. Something like this. It's like target, you know, seconds per frame, basically. Does that make sense? I'm getting very tired. So I'm not sure anything makes sense now. Okay, that's it, no more. You're asking if I'm casting... Where am I casting 1 over 50 to int? Now this is double, this is double. I mean, here I'm subtracting. It's true that I'm subtracting this minus this guy. Yeah, I don't know what I'm doing here. Yeah, you're right. This is probably garbage, right? Yeah, you're right. The static cat, yeah, for sure, this is no good. And this comes back to, like, I don't know how to use chrono. I want to tell it to sleep for that many seconds. Okay, let me just read a bit more about sleep for and chrono and all that. Because you have like this, you can say float here. Yeah, you're right. Yeah, for sure. Can't you tell it to sleep? Yeah, I guess. Maybe, yeah. I mean, everything though I have is in seconds right now. But I guess I could convert to milliseconds. Really what we should be doing is just working with diff here. And if I could figure that out, this probably would make more sense, because then I wouldn't have to do any weird conversions and stuff, right? Like, I wonder if I did like, what would I do? Yeah, okay, so let's say we do milliseconds here. Let me just try. And then what you're saying is, instead of doing this, we just multiply it. So this double multiply by 1,000. So then here we don't lose our precision. Does that make sense? Well, you're saying I could remove the cast to int, but I don't think I can, right? I think it still wants an integer value when you feed the milliseconds, but I can do this. And this way, when it's, you know, like, we should be able to keep enough precision in there. Hopefully. This is probably the thing that's going to force me to learn chrono properly. Oh? Oh, that looks more promising. Yeah, sorry, I gotta keep the focus on the window, otherwise it doesn't get enough CPU time. So yeah, this looks a lot closer, right, to what we were hoping. Oh, I think we actually did it. Okay, that's cool. I mean, I still find the numbers not great there. I was hoping to see something a bit closer to 50. There's probably something I still need to fix in here. So this I'll definitely like mull over it for a little while. Now before we go, because I do want to end my stream soon, there's just one more thing I want to do, which is I want to try that pinball game. The one that like zoomed in too much. Which was what again? What's it called? The pinball game that I was playing. Okay, wait, hold on. I know where to look. Whoops, not that. Here, in my compatibility list. Spinball. Zooms in too much. So now that we fixed those 3 instructions, I'm wondering if Spinball will actually work properly. So let's see. Oh yeah, you're asking if that reduced the CPU load. Good question. Let me check. Yeah, let me check. Let's let it run a little bit. You know what? Not really. It's still got a 20%. Although, is that less? That might be less. Let me see. Maybe it did reduce it. Let me like just comment out what we did and just compare. Basically, if we don't do this, I like this this remix here, Castlevania remix. Prussian Bones. Let's see. Now I'm getting pretty similar CPU times here, so I'm getting around 22% CPU usage. So yeah, not what I was hoping for, but again, you know, I'll just gonna, you know what, I'll take my shower and I'll think about it. So okay, before I go, let's just try Spinball. Let's just see if Spinball actually works. Spinball. Here we are. Awesome. So yeah, it must have been related to rotate left or rotate right. Oops. This game is really cool. I can't believe that they made a pinball game on the Vectrex. How does this work? Alright, one of the buttons is pause. It's cool, right? I mean, hey, thanks for the follow, Douglas Korea. Appreciate it. Oh, I see, and I can tilt when I use the analog, and I can even choose the direction of tilt, and I over tilt it obviously. See if I tilt, I guess I have to wait till it's in play. That's a left tilt right there, a right tilt, a forward tilt, and a back tilt, and I tilt it too many times. See, unfortunately I don't have an overlay for this game. I'm gonna ask there's like a Vectrex community that I follow on Facebook. I'm gonna ask them if there's like some collection of all Vectrex overlays that people have collected so far. Because I've found like a set, but obviously some of the commercial ROMs are missing. Hey Douglas Korea, you like my Matias Pro keyboard? You have one as well? Yeah, it's a really nice keyboard. You know, it's funny that you should mention it, because just this week, I think Raptor, if Raptor is still in chat, Raptor Faxes, anyway, we were discussing this, that the reason why I bought this keyboard is because I was looking for a split mechanical standard layout keyboard, which when I was looking for this a couple years ago, there were actually nothing that fit those criteria. You know, there were split mechanical non-standard layouts, or there were split standard that were non-mechanical, but to have the three together was impossible to find. And then Matias made this keyboard. Oh yeah, so you have two keys broken? Oh, that sucks. So have you contacted Matias? Because they're usually pretty good about repairing these things. Anyway, yeah, so I found this keyboard and I was really happy because, you know, it's fairly standard layout. I mean, the only things that are a little bit weird are the little cluster over here, but you get used to those pretty quickly. Yeah, exactly. So the keyboard of choice for me before this one was the Microsoft Ergonomic 4000. But the thing is, it got really, really mushy over time. They like kind of cheapened out on the parts over the years. It was a decent rubber dome keyboard, and then they just got worse and worse over the years. They kept making it cheaper and cheaper, so I just couldn't type on it. I bought a new one, and like after a week, I was like, I can't. It's just too mushy. Oh, you're in Brazil. Yeah, that's gonna be tough. But what I wanted to say was, I saw that there is a new keyboard that Kinesis are making. So it's a Kinesis, it's a gaming keyboard. Well, they call it a gaming keyboard, but it's really, let me see if I can find it. Hey, what's up, the Corey Show? So this one right here, the Freestyle Edge. So this is actually yet another split mechanical standard layout keyboard. Let me see if I could find like a good picture or something. Here. Oh, you can kind of see it here. I don't know if I can get like a nice close-up. And you can get like you can be tented as well. You have a bit more control with this one. You can do 5, 10, or 15 something. It's fully programmable. So it's really nice. Only thing is it's rather expensive, but it looks like a beautiful keyboard. And it uses cherry switches. That's one thing too, is the Matias uses their own switches that are based off the old Apple switches, which I like. But if anyone's looking for one that uses cherry switches, this is one that will use them. So yeah. She's saying the Ultimate Hacking Pro is splittable too. But is it standard layout? The Ultimate Hacking? Oh yeah, that one. Yeah, that's a cool keyboard too. A lot smaller, right? Yeah, this is a nice keyboard. But you know, the thing is, for me, like what I really liked about the Ergonomic 4000 from Microsoft was the fact that it had like the negative tilt to it, you know? And I find like a lot of these keyboards, like this one here, doesn't have that. They're meant to be flat or even worse, raised in the back. You know, at least this keyboard here, you know, it is meant to be tented and somewhat negatively tilted. You can actually configure it to be have either a negative tilt downwards this way, but then no tenting. So here with the Matias, you have a choice, right? But what I really would like is to have both, like to have both the tenting and the negative tilt. So if I could raise the front like this, then I think that would be the ideal keyboard. It's true that a smaller keyboard is easier to transport for sure. But yeah, I mean, I guess this one, depending on how you configure it, I think for this one, you have to buy parts separately. So the keyboard that you get looks like this. It has no pads on it. You can buy the pads separately. It has no tenting. You have to buy the tenting kit, the lift kit they call it, separately. So I mean, this one turns, you know, is quite expensive once you put it all together. But like I said, you know, you get the cherry keys and all that. So anyway, that's keyboards. So yeah, I'm looking at the time, guys. I think I'm gonna stop here. Very happy to see that we fixed Spinball, and now I have to go through a whole bunch of other games. I'm gonna actually run the synced version with the 2 instances with a bunch more games to see if I can find any other discrepancies. But yeah, it's gonna be cool. So we'll solidify the CPU, and then I can go through this compatibility list and kind of go back over the ones that had problems and see if they've been fixed now. So yeah. Oh, thanks, Knack Hackett. Great to have you. It's great to have all you guys. So thanks for watching, and hope to see you guys in a couple nights. I'll be streaming again on Wednesday night. So yeah, thanks a lot, guys.